Currently in a Ford Focus. This is a 2004. It's got the 2-litre engine in it. It's got an issue where you're coming up to stoplights or traffic lights and it could cut out. So it's an intermittent problem that it has. I have fixed this type of issue before, so in this video I'm going to be showing you the item that causes it, where it's located, and how to install it. So the problem is caused by this unit here. It's an idle air control valve. Fords have had issue in this age range with these items. The likes of the Ford Ka, Fiesta and Focus, all of different engine sizes and capacities, have this issue in it. So if you have a vehicle that coming to a stoplights or traffic lights and has an intermittent issue where it's cutting out, it could be this part here. So idle air control valve. Cleaning of these isn't that successful. I have tried that in the past as well, have found it to be of no success. In some of the other engines where it's very easily accessible, I would definitely try it. You could try and clean it out and see if it helps. On this engine it's located in quite a tricky spot, so I definitely won't be cleaning. This will be a replacement. So let's go ahead and replace this item now.
So I just skipped past the very simple stuff to remove, which is the air box, air filter and intake pipe and the battery cover. Very simple and straightforward to remove those. And now we have those out of the way, you have clear visibility when you reach down in and view that idle air control valve. It's sitting up there in the underside of the inlet manifold, and it's held on by two 8mm bolts. That electrical connector at the end is a very simple one to remove. It's just a push down and pull back connector, and I use a 1/4" ratchet. This is my deep 8mm socket for the top side, which makes it very easy to remove that. The lower side is more difficult. I do use a longer ratchet to initially break it away, but you can rotate the shorter ratchet to, let's call this 3 o'clock to 9 o'clock position, and you're able to ratchet away easier if you do that. This is the old part on the bench, and I'm just showcasing the actual failure. So I have it hooked up to a 12-volt supply, clicking on and off. And as you can see, it's completely jammed with zero movement. The new part is installed. Just take your time, be patient, and you will have no issues putting this back together. If you are, it's just 2 bolts holding it in with a new gasket. Okay, so I've got the idle air control valve here. This is the faulty one. New one is fitted, as you've seen, and it has rectified all issues. No more running problems, no more cutting out, and that vehicle is much happier now. So these are a very common problem. I've been diagnosing these for over 20 years. One of my first vehicles ever was a Ford Ka, and one of the first complaints that I had on that 1997 was cutting out at traffic lights. An embarrassing thing to be happening in your first car. It turned out to be this one. Fitted one of these, fixed the problem. Didn't know much about them at the time, but now having a better understanding on how they function and what they do, I'm going to show you some quick and simple checks. Okay, first of all, to check the circuit, which you didn't see in the video, having this disconnected, you could pop in the likes of a Noid light, or if you have any type of voltage testing, and you can check to see the voltage coming down to the actual connector with it disconnected from here. Very simple and quick check. Noid light's very nice because you can flick the key on and you have that output coming down to it, and you see a visual result from there. So that's a great way of doing it. Otherwise, if you have the capability, so if you are in a workshop or you have accessibility to a scan tool that has live data that shows the operation of this, a very quick and easy way of looking at it is to see if you're getting a reading down. So making sure there's actually an operation happening, and you can also get on the signal and with your lab scope or oscilloscope, check to make sure that you're getting the correct type of signal down there. These fail mechanically, not really electrically. I haven't seen a wiring issue. I'm not saying that it hasn't happened, of course it has, but they're less likely to have any wiring issue or electrical failure. The resistance of these can be checked as well. Do an ohms resistance check, which I can do in a second and show you, but these tend to always be mechanical failure. They get stuck, they jam, they free out, and that is the issue with this one here as well. And we have 10 ohms of resistance. That's just changing there as I'm moving, but we've got 10, so that's perfect. No issues there on that side. And I'm going to go ahead and do the voltage straight down on this unit now. So I've given you the best angle I possibly can. Look in right here for movement. You should see very little or none at all. There's a voltage applied there now. And see how we got some movement. Do it again. And as I hit it, it's moving back. So see, it releases and then it's not moving again. See, we're starting to get a bit of movement. And watch it retract back when I hit it. I'll release it now again. Really hope you enjoyed this video. Hope you found it useful and informative. If you did, please like, share, comment and subscribe. And I hope to see you in the next one. Thanks for watching.